Thank you, Sam. Appreciate it. Good afternoon, everybody. I'm glad to see we have a full house. And I hope all of you have been enjoying this expo so far, because I think it's one of the best places where the company like ours, which is a startup, can meet with the companies like NEOM, AIRBUS, and especially Sam Near Horizon, which it help us to not just invent, but propel and physically introduce our product to the market. M-CYCLE is the technology invented by Dr. Professor Maisotsenko, and technology which is fundamentally different from today's way of deriving and utilizing energy. And if you've been at this conference, we see how big of advancements are today in the electric vehicles. And our panel just mentioned that in 2016, 5 or 6 years ago, there was just maybe a few vehicles and a few brands which could do that. And now there is a whole after whole of electric vehicles. And the technology which also advanced from the perspective of the artificial intelligence, which help us to create virtual sensors, synthetic data, and help us guide to our parking spot faster so we can reduce the carbon emission while looking for a parking space. And I sometimes ask myself, why do we have to go to the extreme of artificial intelligence to improve efficiency and reduce our carbon emissions? And in order for us to understand that and move forward, I think we need to take one quick step back and take a look in the past. Where did we converted the heat into the mechanical work, and what is the cornerstone of how we derive our energy today, especially for mobility. I don't know if there is any specialists in the house, but you probably recognize this is a cycle Carnot, which depends on high temperature, creating pressure and value difference, which drives our cylinder or a turbine. And the formula is quite simple. The useful driving force we derive is the difference of high temperature, low temperature, and then the CP stands for the property of our heat carrier. And the heat carrier is simply air, right? Because we compress the air, we combust the air, and then the air does some work. It's a little dirtier, but we expand. But it didn't change its state. It was air when it began, and it is air when we finished. So when a professional looks at this, nobody questions that, right? If your specific heat does not change, you can pretty much disregard it. And I think that was one of the misassumptions on the part of the scientific community, not to question something which was invented in 1824. Dr. Professor Valery Maisotsenko, he must have been in his younger years. He missed the lecture that the cycle Carnot is the best what we can have. And he looked at the equation and he said, why are we only dealing with one element of that formula? What if we are able to create driving force or derive more work through changing how we and our heat carrier operates in an engine? Again, I apologize for the specialist. This is technology which was invented in 1975 in the former Soviet Union. Later, it's been patented by the former Soviet Union. And since then, it's been improved and introduced and accepted by academia around the world as one of the best ways to producing energy. Again, and I apologize to the specialist, this is a psychometric chart. This is the chart describes the property of our heat carrier in case of air, relationship between temperature and humidity. And if you notice, it says that we know that in dry air, we have energy. It's called kilojoules per kilogram of dry air. The question is, why did we not access this energy in a way we can do today before, since it's been known since the Pharaoh's time? And it's because until 1975, it was thought that the best you can do is to achieve the difference of that little bit delta H between the difference of the dry thermometer and the wet thermometer. And unfortunately, that range, as you can see, is very small. What Dr. Professor Maisotsenko figured out how to increase this range. And again, as you can see on the chart, the temperatures between dry thermometer and dew point is much larger. But most important part of this technology comes in aspect that with the slightest addition of heat, by adding just a little bit of heat via solar, via recovering waste heat from electrical battery, from internal combustion engine, we can exponentially increase our driving force. Now that I put half of you asleep, I was going to do a demonstration to you how we can have a small device, and that device containing no moving parts can take an air of 100 degrees, 200 degrees, 300 degrees, and still cool it in the same pass to 17. Alice, that wasn't possible. So I invite all of you after the presentation to come us and see us with Neo Horizon in the AIRBUS booth in the open area by the bike track, and I can demonstrate this principle to you live. Here is just a very short video because I think it was very important point that we should do more than just patents and idea. We need to provide prototype and testing for this equipment. So technology which is based on M-CYCLE is now a family of third generation of our product. You can see it contains nothing but water. That's what powers our technology. And I thought that if it's time for us to have electric vehicle, we should have to have electric battery-powered air conditioner. Dr. Professor Maisotsenko, for his efforts, was awarded over 300 patents, and now our latest venture, family-owned M-CYCLE Industries, is covered with the 32 brand new patents. It's been recognized by some of the major universities around the world, expos, and more recently, close to home, this is the article from University of Mons in Belgium, which says M-CYCLE has the highest waste heat recovery with the highest electrical efficiency, and compared to most other technologies, we do combine 4 separate individual components into one. So the system is simplified and made more dependable. And of course, one of our latest awards by Neo Horizon AIRBUS, thank you, Sam, which allows us to address you today. So one of the unique value proposition, we can increase the capacity when the demand increases. We can recover over 90 or up to 90% of energy. And today we have developed new material application which allow us to do in a temperature sufficient for the mobility, for cars, for airplanes, and for pretty much anywhere where we utilize energy. Also, in 2020, United States Patent Bureau has granted us first, principally new engine, since the engine was invented in 1824, which did not depends on a combustion, but depends on a difference of enthalpy of dry air and wet saturated air flows. Application for this technology, we heard the cooling is obviously a big issue. The electric vehicles, we can offer in a single package cooling for the cab and cooling of the batteries. And when the rest of the world's trying to disperse the heat, like through the radiator, for example, we take that heat and we convert it into the additional electricity or cooling capacity. Public freight, refrigerated transport, it's been already proven numerous times it helps to reduce NOx poison emissions by over 10 times and the CO2 emission 3 times. So pollution and the carbon offset, and the scientific articles on this has been coming out almost on a daily basis in the last few years from a number of different and very prestigious academic institutions. And obviously the waste heat recovery, some of our latest patents in Brayton cycle, turbines, Otto diesel cycle for internal combustion engines, and over 80% recovery rate, again, been demonstrated time and time over. Let's review real quick. So some of the most key components we offer is the mobility for the air conditioning sector, especially in the electric vehicles, waste heat recovery, and elevating other renewable energy such as solar and wind, increasing their capacity, and as thermodynamics offers that, it's obviously that not a single application can be achieved, but once we derive the energy, we can convert it for different purposes. Mechanical propulsion, cooling, heating, production of electricity. So it is fundamental shift. Is it feasible? Well, our previous generation of products established and built in Denver, Colorado in 2000 are now installed around the world, mostly for building applications. It's embraced by United States military, all its branches. It is capable of mobile applications, and F-35 program utilizes this equipment. And the key points were operating cost reduced by 80%. There is maintenance expenses, there is no refrigerants to be refilled, there is no components to be changed, and most important, it's providing you with the comfortable environment. 100% fresh air supply. No COVID, we do not rely on the recirculation. We are short on time. There is another company here which is also presenting extremely important solution. So I'm going to be turning it over to them. I propose for you to stop by and see us after the presentation, where if you'd like to see it live, I will show you how we take 100-degree temperature using no external source of power and cool it to 17 degrees. I appreciate your attention, and I'll turn the floor to Kostya, who will demonstrate to you the going beyond the zero, but not reducing carbon solution, but removing carbon which is already in the atmosphere. Kostya, thank you very much. Kostya!
Hi, hello.
Thank you.
Thank you, Stan. Oh, the stage is burning after him. But all right,